If x minus 3 is a solution to this polynomial equation, that means that when I substitute 3 into the place of x, everywhere I see an x, and I evaluate that expression, I should get 0. The remainder theorem, on the other hand, tells us that if I'm using x is equal to 3, if I was to divide this original polynomial by x minus 3, that I would get a remainder of 0 because that's the value of the function. So understanding that, we can see that there's an equivalence between being a solution and your quotient having a remainder of 0. So understanding that, if we don't want to go through the trouble of substituting in numbers for x, we can go through the trouble of doing some synthetic division, working through a factorization, and finding the solutions from that. So I want to show that 3 is a solution. In order to do that, I'm going to show that x minus 3 is a factor and it has a remainder of 0. So we'll start with our 3. We follow with our coefficients. As always, even though in this case it's a 2, we bring down our first coefficient. Multiply and add, multiply and add, multiply and add. And because our original polynomial went x cubed, x squared, x and a constant, we know that our quotient is going to go x squared, x, the constant, and the remainder. If this was a question strictly about the remainder theorem, this is where we would stop. We would recognize that x equals 3 gave us a remainder of 0. That means that it's a solution, and we would be done. However, we have this second part of the question that's creeping in that tells us that we need to find the remaining solutions. And we can do that by understanding what division actually does for us. What division actually does for us is it allows us to re-express the dividend, in this case 2x cubed minus 3x squared minus 11x plus 6, as a product of the divisor and the remaining quotient. And of course, we want all of that to equal 0. But we're going to wait on that part for just a second. Oops. Okay. So right here, we're going to see from this factored version of the polynomial, this is where we're getting our answer of x, our solution of x is equal to 3. But it's from this, the leftover quotient, where we're going to get the remainder of our solutions. We check to see that this polynomial is factorable, which it is. We can factor it as 2x minus 1 and x plus 2. And if you're not sure of that factorization, feel free to go through the AC method. And with these three factors, I get three solutions of x is equal to 3, x is equal to 1/2, and x is equal to -2. Written as a solution set, we get -2, 1/2, and 3. 3 solutions after understanding that the first one came from a division. Now, either this one or this one, as those two factors, they could have been let off. They could have let off this problem. They are linear binomials with a coefficient of 1. I could have started by dividing x minus 3, which I did, or I could have started by dividing x plus 2. I could not have started with this one, as it does not have a coefficient of 1. But if I can start with either of these other two, if I can find either of those other two easily identifiable answers, it can walk me to the other ones based on the factorizations that I already know. It's the remainder theorem that ties together this with our understanding of solving. If we know that our remainder is 0, we know that we equal 0, we know there's nothing left over, then we have the value of the function at that point. We can do our continued factorization and get the remainder of the solutions. Obviously wanting all of this to equal 0.